Today we're going to talk about exponential and logarithmic functions and their graphs. The first thing that I'd like you to do is make an XY chart and plot some points for y equals 3 to the x and draw a sketch of how you think it should look. Press pause when you're ready to see the answer. Press play again. Okay, you'll notice as x gets smaller, your y value will get closer and closer to 0. However, it will never be less than 0 or even equal to 0. So my graph looks like this. I have a horizontal asymptote at the x-axis, and it increases. So now I'd like to talk about a new parent graph. Y equals a to the x is an exponential function. I can change the value that a is, and that's a real number raised to a power. So in general, I want you to graph at least 3 points. Those for x equals -1, 0, and 1. If x is -1, y is 1 over a. If x is 0, y is 1. If x is 1, y is a. You'll notice that the domain is all real numbers, negative infinity to infinity. There won't be any problems with substituting any real number for my exponent. My range, however, is from 0 to infinity. That's because no matter what negative power I put on my x, I will never ever get a negative value. Ooh, and there is a problem with my I have a typo, and it should not include 0. So let me change that. So our graph will never actually be equal to 0. So I need a curved parenthesis there. And my horizontal asymptote is y equals 0, or the x-axis. And my y-intercept, no matter what the base is, will always be 0, 1. Remember BCAD? Remember transformations? Well, we're going to use transformations to graph our exponential functions. So I have the general form of transformations written on top, and then I have specific to an exponential function. Remember, with the vertical movement is caused by a. It causes reflect over the x-axis. That's when a is less than 0. If a absolute value of a is greater than 1, it causes a stretch. If it's less than 1, it causes a shrink. With horizontal, reflect over the y-axis. If b is less than 0, if b is greater than 1, it causes a shrink. If b is less than 1, it causes a stretch. With horizontal shift, that's caused by c. If c is greater than 0, it shifts to the left. If c is less than 0, it shifts to the right. D would cause our vertical shift. D is greater than 0, causes my graph to move up. D is less than 0, causes my graph to move down. Notice that the b is factored out of x plus c. That's really important. I want you to look at this function, and I want you to identify what a, b, c, and d are. Press pause, and when you're ready to see the answer again, press play. So a is 1. It is the number that's in front of this 2. B is 1. It's the number in front of the x. C is 1. I'm adding 1 to x, and D is -2. My base on my exponential function is a. The next thing I want you to consider is how A, B, C, and D will affect the parent graph. Press pause, and when you're ready to see the answer, press play. Okay, so A is 1, B is 1. It will not stretch, shrink, reflect vertically or horizontally. It will move to the left, and it will move down. The next thing that I want you to do, and this is on the next page of your guided notes, I want you to fill in your XY chart according to this parent function. You'll notice I've told you that the horizontal asymptote is always going to be y equals d. In this case, d is -2. So my horizontal asymptote is y equals -2. Fill out the values for the parent graph, y equals 2 to the x. When you're ready for the answer, press play. Okay, so you'll notice at -1, my parent function is 2 to the -1, or a half. You'll also notice that I put an extra value on here. The more values that I can put, the more accurate my graph is. Now that you've done that, I want you to use BCAD to find the values of these points after they're transformed. Then I want you to plot them, and I'd like for you to draw your graph. Press pause. When you're ready for the answer, press play again. Okay, you can see that I divided by B, which didn't do anything. B is 1, and I subtracted C. C is 1, so I subtracted 1. A was 1. I multiplied my y's by A. Since A was 1, it didn't do anything. And then I added D. D was -2, so I was adding a -2. I plotted, and then I drew my curve. And the other thing that was important to draw was your horizontal asymptote. Next, I'd like you to graph this function from start to finish. When you're ready for the answer, press play after pausing the video. Okay, you'll notice I factored out the negative so that A now is 1. It's the number in front of my 3. It's not the 3. 3 is my base. B is -1. C is 2. D is 1. My horizontal asymptote is y equals 1. It was shifted up 1 from D. Y equals D. My parent function is y equals 3 to the x. And then I filled out my XY chart for my parent function. I divided by B. I subtracted C. And then to my y's, I multiplied by A, and I added D. So what really has happened here is I have reflected my graph over my y-axis. B is -1. C equals 2 has caused my graph to shift to the left, and D equals 1 has caused my graph to shift up. The next thing I want you to know is the number E is an irrational number, and it's used as a base frequently. We will talk about that more in a future lesson, but for right now, you just need to know that E is an irrational number that shows up in a lot of problems in real life. The next thing we're going to talk about are logarithms. A logarithm is written like this. Log of a bit to a base of y is equal to the exponent. So if you're looking at it to translate a logarithmic expression into an exponential expression, you take the base from the log, you raise it to the exponent, which is what a log is, and it's equal to the argument, y. So I'd like to evaluate these logs. I showed you how to do the first one. 2 is my base. I said 2 to what power, because a log is an exponent. 2 to what power is 32, and the answer is 5. Press pause, evaluate these other 2 logs. When you're ready to see the answer, press play again. Okay, number 2 is a half, because 4 to the 1/2 power is 2. Number 3 is 3, because 3 to the 3rd is 27. One more thing about logs. If you write a log like this with no base, it is assumed to be base 10. If you write ln, it means log base e. Log base e of 1 is what I've written. Evaluate those real fast and press pause when you're ready to hear what these are. Press play again. Okay, log base 10 of 100 is 2 because 10 squared is 100. Natural log of 1 is 0 because e to the 0 is 1. The next thing we're going to do is graph a basic log function. So whenever I graph these, I rewrite them in exponential form. It's easier for me to deal with. So I rewrote this as 2, that's my base, to the y. A logarithm is an exponent, is equal to the argument, x. Then I put -1 in for y, and I find 2 to the -1 is a half. I put 0 in for y, I get 1 for x. 1 in for y, I get 2 for x. So our general logarithmic function has a vertical asymptote at the y-axis. And once I plot these, you can see that the log is increasing. Our logs will always go through 1, 0. And also you should notice that logs and exponential functions are inverses. I essentially just took my x's and y's and switched them if my equation had been y equals 2 to the x. More on that in a future lesson. Now, we have another parent function. It is a logarithmic function. And again, I want you to make sure that you are always graphing at least 3 points. So you'll notice that it's just flipped from what the exponential graph was. My domain I have to fix. This should be a curved parenthesis. So my domain is from 0 to infinity. My range is from -infinity to infinity, and I have vertical asymptote at x equals 0. My x-intercept is 1, 0. Notice my domain is 0 to infinity. My range is all real numbers, -infinity to infinity. My vertical asymptote is my y-axis. My x-intercept is 1, 0. Now, the next thing you should do is identify what A, B, C, and D are in this graph, and also the vertical asymptote. Notice that my vertical asymptote is only affected by any kind of horizontal shift. So my vertical asymptote is going to be x equals the opposite of C. Press pause when you're ready for the answer again. Press play. So my vertical asymptote is at -1. A is -1, it's the number in front of the log. B is a half. C is 1. Notice the half is factored out. D is 0. Graph the function. Press pause when you're ready for the answer. Press play again. Here's my answer. My graph has stretched horizontally. It's reflected over the y-axis. It has shifted to the left 1. So I took my parent function values, I divided by b. I took my x's, divided by b, which is like multiplying by 2. I subtracted c, that meant I was subtracting 1. And to my y's, I multiplied by a, which was -1, and I added d, which was 0 and did nothing. My vertical asymptote is at x equals -1. I plotted my points, and I graphed. That is the lesson for today. Now I'd like you to work on the assignment that's posted on Schoology. Have a great weekend.